Hey guys, I'm gonna give people a couple minutes to join and I'm gonna kind of like get this setup situated because I tried to find a way to set this up without dropping the board on my feet like multiple. So, okay. Hmm. Okay. Can you guys let me know like if that's close enough or if you can see? Because it seems like to me you can't see that well, like the lighting's off. Hmm. Does it look to you guys like the light's bouncing off the board too much here? Because like for my screen, it looks like there's way too much light and you can't even see the whole thing. Okay. Let me try to like turn the setup then, make it better. Done? Okay, well mine just started. So you can go ahead and play. Tell Nikki he can come back up here. Tell Nikki he can come back up here. Let's see. Is that better? Like I think it's kind of like close now, but can you at least like see the text on the board? Okay. Let's see, is that far enough? Okay, I think we can make work with that. All righty, so what we are gonna start with is we are going to go over the questions that I said for you guys to try by yourself last time. So I'm just briefly going to mention Ionic Covalent again, because I know that some people started like watching the videos now. Like some people weren't able to make it to all the live streams. So I want to try to like, you know, add a little bit of review in for those people. But okay, so what we're dealing with is we're dealing with ionic and covalent bonds. We are looking at how the ionic bonds are formed and specifically now getting into how do we identify an ionic versus covalent bond so that we can use the proper naming for each one of those. So just as a review, and this is something that we mentioned before we left school, for an ionic bond is made up of a metal plus a non-metal. Okay, so the metal is your cation with the positive charge, your non-metal is your anion with your negative charge. For covalent, you have non-metal. Here we are not looking at positive negative chargers because for covalent bond, we do not have a donor acceptor system. Instead, covalent bond was when both entities throw in electrons and they share. So it's not really the same system. It kind of works differently there, okay? But what you need to know for these purposes is ionic, metal first, followed by nonmetal, covalent bond, nonmetal, and nonmetal. So I'm gonna pull up the sheet from last time. I want to show you guys how to access it just in case you weren't able to. So, where's my, oh, that's why. Okay, give me a second. Yeah. Okay. So this is where I uploaded the information. I thought it might kind of be easier instead of giving you so many new announcements. So up underneath pages on my Canvas page, what we are going over and what we've been going over is formation of binary, ionic, and covalent, otherwise known as molecular compounds, charge balance, IUPAC naming, and property predictions. So we've pretty much gone through everything except for the IUPAC naming at this point. So if you scroll down here, so here is the standard of basically telling you everything that you need to know, or everything that we had to have covered, which we pretty much did at this point. Here you have the PowerPoint that I went over the other day, and then here is the actual file that we're going to go over. We started on the left-hand column 1 through 10, and then I asked you to finish the rest of the left-hand column followed by all of the right-hand column. And then here's some additional resources for you guys to practice, because right now what we're doing is exactly what you're going to be doing in chemistry class. And if you have not been exposed to it, you will be totally lost, and that will kind of, I'm not going to say necessarily put you behind, because at this point, you know, everyone's behind just their situation, but it will just like help you, make you that much stronger if you're at least exposed to this now. Okay. So, okay. So let me go to the sheet. Where's the sheet? Interesting. I swear I had, oh, duh, I had it pulled up on here. That's right. Okay, so I didn't even have to stop sharing. Look at that. Okay, so here's the sheet. Basically, you could have just clicked on it from the Canvas page, and I actually already did that and accidentally forgot. So anyway, here we are. We are going to finish the sheet. So at this point, you guys can unmute yourself, because I'm going to just ask you the general naming rules, and I'm going to put them up on the board for reference, and then you are going to tell me how you named each one of the species, okay? So let's just start off with the general naming rules for the ionic. Can you tell me how you name an ionic compound? What do you remember?
The metal is written first.
Okay, so you named the metal first, and do you change the name in any way? Like the name of the metal?
No.
No, okay. So for an ionic bond, you start with the name of the metal, and then what?
Name the non-metal ion and using the first syllable of its element name followed by "ide."
So non-metal followed by "ide," and I'm just going to put like a little first in parentheses here because there's not going to be any room. But first syllable followed by "ide." Very nice. And there was a special case for the naming for the ionic compounds. What was that? There was one instance where you have to take an extra step.
That's when you have the subscript, you put like the tetra and stuff.
So that's for covalent. So for ionic, it's when you have a metal and a non-metal. So in general, for pretty much most, oh, I can't even say most, for maybe actually a little less than half, maybe, you would use this, the general naming, but there's a special group of metals that behave a certain way. And we have to approach their naming by adding something extra. What is it?
I.
You said I?
I'd.
Well, all of the non-metal endings get "ide." I'll give you a hint. It has to deal with the transition metals. So transition metals can have different charges. So how do we know which one we're talking about?
Oh, Roman numerals.
Roman numerals. So if we are dealing with a transition metal, trans here for transition metal. So then you name your metal, and then you have your Roman numeral. So I'm just going to kind of put a number in here, number symbol, and then still non-metal followed by I, first syllable. Very nice. So for the metals, for the transition metals, if it has more than one charge, okay, only if it has more than one charge. If I remember correctly, there's only 4 transition metals that have one charge. Like it can only form one ion, but the rest of them can form multiple ions, all the way from 2 different ions to 10 different ions. Maybe a little bit more for some of them, I'm not sure. But you would put the name of the metal, and then you would have to put the Roman numeral that indicates the charge of that specific cation, okay? So it's not talking about the non-metal, it's just talking about what charge does that transition metal have, because you could have a bunch of different charges for that metal. So we just need to know, well, which specific one are you talking about? And then followed with non-metal I. Okay, good. So what about the covalent naming? Somebody already mentioned it. So how do we name a covalent compound?
The first non-element in the formula is named by its element's name.
Okay, so first non-metal, you just put like the non-metal full name. Okay, and then what? Hey, chill. What about the second non-metal?
It's named using the first syllable of its element followed by I, and
So
then prefixes.
Okay, good. So basically, the first step for both ionic and covalent is you name the first element just how it is, and then you name the second nonmetal using the first syllable followed by I. But now the change with covalent is for both, you need prefixes. You start both with a prefix. But what was the exception? What was the prefix that we don't put?
Mono,
Okay, so except for mono, when?
for the first element, first non-metal.
Right. Except for mono for the first one. So you should never see mono something and then, you know, second non-metal, because for the first element within the compound, or for the first part of that compound, it is understood that there's just one of them. Like it's redundant. There's no reason to have that. Now, something that I did not mention during the last meeting was why there are prefixes, okay? So in a covalent compound, there are prefixes because we are talking about sharing, about elements throwing their valence electrons together. And like, for instance, we have, and I don't, yeah, you guys can see it. There is CO, CO2, CO3. How would we possibly know which compound we're talking about unless we have the prefixes? Because both of them, or all 3 of these, are made up of both carbons and oxygens, right? But there is a difference between carbon monoxide, carbon dioxide, carbon trioxide, which this actually has a different name. But there are differences between them, okay? So each one of these behaves differently, right? We talked about during the last meeting that carbon monoxide is basically poisonous to us. Like if we inhale it, like it's odorless, it's colorless, because it's a gas. Like that's what makes it so dangerous. We don't know when we're surrounded by it unless we have a detector. So it's very important to be aware of what gives off carbon monoxide and to have detectors in your house, because you wouldn't know that you got basically poisoned from it until it's too late. We talked about the fact that cars give off carbon monoxide, cigarettes give off carbon monoxide, which is one thing that makes them very dangerous too, and to those around you. If you get, if your lungs become overwhelmed with monoxide, it cannot bind oxygen anymore, cannot bind and release it. Therefore, you end up like choking, you can't breathe anymore. So very, very dangerous. Whereas carbon dioxide, We breathe out. It's part of our cellular respiration, right? Like we take in oxygen, give off carbon dioxide. Part of the atmosphere is made up of carbon dioxide, so clearly it's not detrimental to our health. So all it took was that one extra oxygen to make the change. So it's very important to indicate exactly what you're talking about, because as you change these, like in it, as you change the elements within the compound, all it takes is just one element difference to completely change the behavior. Okay? All right, so now let's get into going over the answers from the sheet from yesterday. So keeping this in mind, please, feel free to use your notes if you weren't able to do it. If you were able to do it, you can tell me your answers, but let me figure out how I can type this again. Okay, how do I do this? Like that? Oh my gosh. I think I'd have this figured out by now. Oh yeah, there it is. Okay. Alrighty, so starting with 11, I want you to tell me ionic or covalent and then tell me the name. And it's the 11, oh wait, no, okay, never mind, it's 1 through 40. Yeah, so the MGS one.
Ionic.
And you guys can unmute yourself at this point so I can hear you. And I don't care if you're wrong. It does not matter to me. All that matters to me is that you try, because it gets confusing, really confusing when they're both in there together.
Ionic.
Ionic.
Okay, so we have ionic. So tell us real quick how you knew it was ionic.
Is magnesium.
Metal.
Because magnesium is a group 2 alkaline earth metal, positive 2 charge. So it's a cation. Very nice. Okay, so what is the name?
Magnesium sulfide.
Magnesium sulfide. Perfect. Metal written space first syllable of the nonmetal followed
Do
by.
we have to include mono?
Not for the ionics, no. So say it again. So you only add the prefix, the mono, di, tri, tetra, penta. You only add those if you are dealing with covalent. So that's really important to be like, okay, is it ionic or is it covalent? Because once you basically like go through that checklist for ionic, you're like, okay, I just keep the name basic, but you need to make sure it's not a transition metal. As soon as it's a transition metal, then you're like, okay, I need to add a Roman numeral. But if you're in covalent, you're like, okay, keep the basic skeleton the same as ionic, but then go back and add your prefixes. Okay? All right, so number 12, ionic or covalent?
I put ionic.
Ionic, okay, that is right, because aluminum is a metal. So is aluminum a transition metal, or what group is aluminum in?
Or metal?
Oh, are we going off the sheet from yesterday?
Yes, we're going off the sheet from yesterday. Here, I don't know if you can see it or if you have your periodic table on you, but here's my periodic table. You really couldn't see that, could you? Because letters are so small anyway. Okay, well, here's aluminum. I'll go ahead and point at it for you. Which group is aluminum in? Which group number based on its location? So 13 or 3, right? So is group 3 considered transition metals?
Yeah.
So group 3 can have more than one charge? What's the charge of group 1 elements when they form a ion? What charge do these have?
One.
Do you guys remember the charges we wrote on top of each group? What charge does group 1 have?
1, I think. Wait, positive 1?
It does have a 1 and it's positive 1. What about group 2?
Positive 2.
2.
Positive 2. Well, then what about group 3?
Positive 3.
Positive 3. So if group 3 has a positive 3, it's if there is a number that we wrote up here, that means that the entire group has that charge and only that charge. So group 3 actually is not part of the transition metals. It's only these in the center right here. Okay? So like when you're like tall group, drop down, this rows of 10, once you drop down, these are the transition metals, and that means that this is when it can have different charges, and this is when we have the Roman numerals written. And so it's important to be able to identify whether it is a transition metal or not to make sure you get the name right. So since aluminum is not a transition metal, and we know that because it has a positive 3 charge for that whole third group, okay, then we know we don't need a Roman numeral in the name. But what are we going to name this compound, Al2O3?
Aluminum oxide.
Aluminum oxide. Now, let me tell you something that I see as a common mistake that students make. When they start seeing numbers at the bottom, so like you see how it's like Al2O3, it's almost like your brain says like, oh, there's numbers, have to have a prefix. That is not the case. First, I make sure you identify ionic versus covalent, because as soon as you see ionic, immediately you should be like, nope, no prefixes. But sometimes if you identify as ionic first, your brain tells you to start adding prefixes when you do not need them, okay? So just make sure that just because there's numbers there, like at the bottom, the subscripts, don't think that means that you're going to necessarily have the prefixes different, okay? So just be like ionic, no prefixes, cool. And then you take that route. All right, well, perfect. It is aluminum oxide. Very nice. Okay, 13. Ionic or
Covalent.
covalent, very nice, because we have 2 nonmetals. Okay, now what's the name gonna be?
Phosphorus trioxide.
So how many phosphoruses do we have?
3.
3, okay. So then I'm just gonna start with the skeleton. So we know it's gonna be phosphorus oxide. So I heard phosphorus trioxide. So are there 3 oxygens? Or how many oxygens are there?
6.
6. So then what's the prefix for 6?
Hexa.
Hexa. So then oxygen is going to have 6 oxygens. So it's gonna be like hexoxide. Well, then how many phosphoruses do we have?
3.
3.
3. So then what's the prefix gonna be for phosphorus?
Tri.
Tri. So then the name for P3O6 is gonna be triphosphorus hexoxide, because that 3 behind the P is talking about the phosphorus, saying how many phosphorus atoms we have, and the 6 behind the oxygen saying how many oxygen atoms we have. Okay?
Okay.
All right. Next one, 14.
This know what we doing what we did the other day.
Uh-huh. Yep. We're going through the answers right now for the ones you guys worked.
Okay.
Iconic.
I'm a little late.
You're good. You're good, Tyler. Okay, so ionic, and what's the name?
Calcium.
Calcium, okay.
Nitrogen.
It is nitrogen, but how are we going to change the ending?
Nitride.
Nitrite. Very nice. Okay, 15.
Covalent.
Covalent, very nice, because we have 2 nonmetals. And if you want, we can just start with like the skeleton and then go back and add the prefixes. I think at this point that might be a little simpler. Okay, so what's the skeleton of the name gonna look like?
Nitrogen oxygen.
Ox,
Alright.
Oxide.
oxide, okay. So how many nitrogens do we have?
2.
2, so what's the prefix?
Di.
Di, nitrogen, okay. How many oxygens do we have?
3.
Penta.
I mean 6.
How many?
6.
6?
It's 5.
It says 05, no? So
That's 5.
what's the prefix for 5?
Penta will be pentoxide.
So it'll be pentoxide. Very nice. Okay, number 16.
Sulfur oxide.
Oh, it's
Okay.
covalent.
So it's covalent, and then I heard sulfur oxide. Okay, so do we need to add anything to that?
Sulfur dioxide.
Dioxide, because it's covalent. Very nice. And if you guys are on here, like I know that it's maybe like the same 2-3 people speaking up, please feel free to speak up. Like, don't be embarrassed. You know, just say whatever you think the answer is and we'll work through it. Because I want to kind of hear from everyone to make sure we're like all kind of mentally working through this. Okay, what about number 17?
Ionic.
Ionic, okay. So what would we name that?
Potassium phosphate.
5. Hey.
Potassium phosphide. Very nice. Okay. What about 18?
So,
Sodium chloride.
All right, and at this point, I'm going to start leaving off whether, actually, no, I'm going to leave ionic covalent on here since we're going over it. I'll leave it off on the other side. All right, so sodium chloride, was that ionic or was that
Ionic.
Ionic? Very nice. Okay, number 19.
Covalent.
Okay, covalent. This is 2 metals. And what would we name that?
nitrogen fluoride.
Okay. Is there anything we need to add? I
The
hear it.
Try.
The tri for trifluoride. Since it's covalent, we need to have prefixes. Okay. And then number 20.
Ionic.
Okay. And the name?
Potassium.
Potassium.
Potassium oxide. Okay. So now that you guys had to try like doing this on your own, how do you guys feel about it, like from the lesson like before to now to actually having to apply it?
Good.
Because this is something that just, it takes a lot of practice, not necessarily because of level of difficulty, but just for your brain to like go through the sorting pattern of, okay, you know, I do this, so I have to do this, and like just trying to figure out which lane to take and then sticking to it. This is really where it gets difficult, where you have to be not told, like I said, whether it's ionic or covalent. So first you have to decide which one it is and make sure that you're like sure yourself, and then stick to that pathway. Don't let your brain be like, oh, there's extra numbers in there, take the other road. No, just
That's what I did.
kind of follow that checklist, okay, to guide you. All right, so now we did not go over how to do this part
No, I'm already at the PE.
the other day. What is happening? I just want to scroll up on the screen.
But did we just pick the PE assignment? Oh, sorry.
Say it again. Are you asking me a question or someone else?
No, sorry, I was on the phone. Sorry.
Okay, so if I erase all this, we're good, right?
Yeah.
Okay, so I'm gonna erase this because now it's not in the right spot anyway. Oh, it shows a little drag mark. I didn't see that either. Okay. All right, so now we are going from the name to the formula. Okay, so once again, you still have to use the same technique, ionic or covalent, because depending on, you know, which one it is, you have to use a different strategy. I will say for these though, going from the name to the formula, covalent is like way easier than ionic because it tells you exactly what to write. But first, we still have to identify which one's which. So, okay, let's start with question number 21. We have potassium oxide. Would that be ionic or covalent?
Ionic.
Ionic, how do you know?
It's a metal, alkaline metal.
Okay, because potassium is a metal, right? So it's ionic. Okay, ionic. All right, so how do you think we would figure out the chemical formula for that from the name?
KO.
Okay. I didn't mean it was okay. I meant, okay. So far we have KO. We know there's potassium and we know there's oxygen. But here's where kind of the tricky part comes in for ionic. We know that the ionic formula is created from the swap and drop, right? So you have to take the name and then do the swap and drop. That is the only way to do these to make sure that you have the proper subscripts, okay? So tell me if you guys can or cannot see this part right here. I'm gonna
I can't
pass
see
the
it.
board to make things a little easier. Oh man, this is gonna be so awkward. Okay. All right, I'll try my best. So we know that we have a potassium and we know we have an oxygen. So using the periodic table, potassium is in group 1. So what charge should a potassium ion have?
+1.
+1.
+1.
+1. So for potassium has a +1 charge. So now oxygen is in group 6, but what charge does group 6 have? So the way you can figure this out quick is how many valence electrons does group 6 want to have, like in total?
8.
8.
8. So we know it's 2 away from 8, but now are nonmetals, do they have a positive or negative charge?
Negative charge.
Negative.
Negative. So a nonmetal is so close to having 8 over here that it wants to get 2 electrons. So it has a -2 charge. So now we have to do the swap and drop. Okay? So let's do it. We have K +1, O -2. What would your chemical formula be?
K2O.
K2O. 1 comes behind the oxygen, 2 comes behind the potassium, and now this is our chemical formula. So we're gonna have K, and I don't know how to make a little tiny 2, so we'll just pretend that 2 is tiny. So we have K2O, and this is how you have to do all of the naming for the ionic, okay? With the transition metals, it does get a little easier because you actually have to look at the charge balance. It's not always as easy as just pulling the numbers up, but usually it is. Okay, so that's for ionic. But now let's look at a covalent. All right, so number 22. So 22 we can see is covalent, right? Because we have the prefixes. So tell me what my formula should look like then, my chemical formula.
N.
N2. Isn't tetra 8?
That would be octa.
N24
Oh, what?
is C? C4, something like that.
So
And
now the tricky part with the covalent is remembering what each one of the prefixes stands for. But once you have the prefixes down, then it's no issue. So keep in mind that the element symbol comes first, and then however many there are, that number comes after it. So it's going to be nitrogen, 2. So N2. Oh, why did I put O? What's wrong with me? Sorry. CO. I was just staring at space. Okay. And then that's tetrachloride. So it's going to be chlorine and then 4 chlorines.
Okay.
So you see how like the name basically tells you how many numbers go in it? That's what makes it much easier. But you have to know the prefixes for that to work. Okay. Ooh, I need to find this on the periodic table. All right, you guys help me out. Rubidium arsenide. Is that ionic or covalent?
Ionic.
Ionic.
Where is rubidium? Aha, there it is.
Group 1.
Very nice. Ionic. I had to look because I could not remember it all. Okay, so 1, and then what about so arsenide is for arsenic. So what group is arsenic in?
Non-metal group
Like what's the group number?
Get back. No.
5.
What was it?
You said 5.
It's in
and
group
then
15, yeah.
group 15. So group 15. So group 15 and group 5 are the same thing. There's just 2 different ways of like numbering your groups. So some scientists took the easy way just to do like 1 through 18 all the way across. But then the group numbers that the other way to name is like 1 through 8, which gives you way more information. But either way, they both mean the same thing. All right, so arsenic is AS. So you guys said rubidium is group 1, meaning we have a charge of +1. So if arsenic is in group 5, what would the charge of arsenic be?
-3.
How'd you get that?
Because
Group
it's
3.
3 away from 8.
Yes, because it is 3 away from 8, and since it's so close to 8, it's going to gain electrons, meaning it's negative. Yay! All right, so it's -3. So now what will the chemical formula look like?
RB1AS3.
Ooh, make sure you do the swapping. So RB, what comes after the RB?
A.
What number comes after it?
3.
3.
3. So the 3 came from the arsenic. RB3AS, what?
One or no?
1 from the RB, but do we ever have to write 1?
No.
No, because it's understood. If something's understood, then we're not going to write it. So that means that our chemical formula is RB3AS. Okay. All right, let's do the next one. Magnesium nitride, ionic or covalent?
Ion.
Ionic.
Ionic, perfect. Okay, so oh my gosh. Okay, so it was magnesium nitride, magnesium Mg. So what is the charge of a magnesium ion? So notice that I'm asking the similar question, but now I'm skipping a question.
It's in the 2.
+2.
Yeah.
+2.
The charge of a magnesium ion is +2. What is the charge of a nitrogen ion?
-3.
How did you get -3?
Because you said what oxygen is trying to get to 8, so it takes away. So, yeah. So nitrogen is you know.
So nitrogen's trying to gain electrons to get to 8. And what group is nitrogen in?
5.
Group 5. And it needs to get 3 more. Very nice.
Yeah.
Okay, so now we have magnesium and nitrogen. We have to do with this information we have now.
Swap and drop.
Swap and drop. So what does that give us?
Mg.
Mg?
3.
3
3 and
N2.
And 2.
N2. Very nice. Mg3 and 2. Okay. All right. Now we've got silicon dioxide. Does anybody know what silicon dioxide is? For like where it's found primarily? It's sand. Silicon dioxide is sand. And it's used to create glass. They heat it to really high temperatures, and that's what our windows are made out of. Silicon dioxide. Now you know. Okay, so ionic or covalent?
Covalent.
Covalent.
Covalent, very nice. Okay, and so how do we go about getting the chemical formula for a covalent compound? Or, yeah.
S.
Okay, silicone is Si.
O2.
And then, so we have 1 silicone, 2 oxygens, SiO2. Exactly. And notice the silicone does not have mono in front of it, but it doesn't need mono. If it doesn't have any of the other prefixes, we understand there's just 1. Okay, number 26.
Ionic.
I heard ionic. Do you guys agree
Yes.
Yeah.
for 26?
Wait, nitrogen?
It's nitrogen. Is it not? I mean, covalent.
Yeah, covalent.
Covalent. So what's a hint? If you're not looking directly at the elements, or maybe if you can't remember if the elements are like metal or non-metal, what's a hint that you see built into this?
The prefixes.
Prefixes. As soon as you see a prefix, immediately it's covalent. And you can always double check. You can be like, nitrogen? I don't know. And then you go back and look. You're like, oh, yeah, that's totally non-metal. So that is covalent, and the prefixes give that away. Okay, well, actually, never mind. Yeah, prefixes give that away. Never mind. Okay, so how would we write this then?
And 3.
3.
In 3?
F.
F.
5.
Very nice. N3, F5. Okay, so number 27, ionic or covalent?
Ionic.
Ionic.
Ionic, okay. So ionic, and then we have lithium and phosphide. Okay, lithium, what is the, what's the
Li.
charge of the lithium ion?
+1.
1.
Plus 1, it is an alkali metal, okay. And what is phosphide? What's that talking about?
-3.
Okay, so it's talking about phosphorus,
Yeah.
and you said phosphorus is a -3 charge. Okay, so what do we do from here?
Swap and drop.
Swap and drop, so that leaves us with?
Li. 2.
3.
Li3. P.
Li3P. So the 3 came down behind the lithium, the 1 came down behind the phosphorus, so Li3P. 3. Okay. All right, number 28.
Ionic.
Ionic, okay. So we have calcium and we have oxide, which is oxygen. So what are the ionic charges for those?
Calcium is +2,
Okay, calcium is +2,
and oxide is -2.
-2, okay. So what happens when you have equal but opposite charges?
It cancels out.
Well,
They cancel out. So then what is our formula gonna look like?
CaO.
CaO. So there's no reason to write it then because the charges have already been balanced. So there's nothing we have to do. So then we're gonna have CaO. Okay. Number 29.
Ionic.
Okay. So we have barium and we have sulfur. So what are the charges for barium and for sulfur?
+2 and -2.
You said +2 -2. Okay, +2 -2. Yep. All right. So then what's our chemical formula look like?
Does it cancel out?
BAS.
It does cancel out. So we're left with
BACL. Oh, I'm S.
BAS. Very nice. Okay. So are we okay up to this point? Do you mind if I erase this and scoot it up a little bit? We're good?
Mm-hmm.
Yes.
Okay. So we were at 29. Okay. At this point, I'm not going to work it out. I want you to tell me. So I'm just going to tell you the name and you tell me, and I'll just verify with the periodic table. If it's incorrect, I will let you know, but otherwise, we're just going to go through these. All right, so question number 30.
Ionic.
AL. 2 BR3.
Say it again.
AL2 BR3.
Okay, where did the 2 come from? What charge does bromine have?
2, +2. Wait.
-1.
That's what I thought. I thought it had +2.
Bromine does not have a +2
That's
charge.
barium.
Br. Yeah, I think you're looking at barium, Ba. Bromine is Br.
I'm not looking at a periodic table. I'm just going off like some I remember.
Oh, that's going to be really difficult. Why don't you pull one out? That's too difficult. You don't ever have to remember that. That's on the periodic table. And you can go to ptable.com if that helps you, but I think it does. It has like the charges written up under there. So bromine is a halogen. It's in group 7. So it has a -1 charge. So then it would be Al1, but the other part's right. So then it's Br.
BR3.
Br3. So
BR3.
aluminum has a +3 charge. Nice, okay. Number 31.
I'm gonna leave that one to y'all.
Say it again. Is it ionic or covalent?
Covalent.
Okay. All right, and then what's the name? Or sorry, what's the formula?
S36. O6.
Yeah.
S3O6.
S3O6. Okay. Number 32.
I didn't know Palladium before.
Ionic.
Ionic, okay.
You said 32?
32, yep.
Yes.
FRO, right?
Uh-huh. But do we have any subscripts from the charges?
Mm.
No.
FR2O.
Okay. So you said Fr2O because francium's in group 1, so it has a +1 charge. Oxygen is in group 6, meaning it has to have a -2 charge. When you pull the 2 down, that'll be Fr2O. Very nice. Okay, number 33.
Ionic.
Ionic.
Very good. Okay.
Al2Cl3. I think.
Chlorine is a halogen. Chlorine is in group 7. So tell me again. So if a halogen is in group 7, then how many electrons does it need?
1.
1.
1. So aluminum we've established is in group 3. So it has a +3 charge, but then chlorine is in group 7, has a -1 charge. So what happens when you swap those charges?
ALC.
AlCl3.
There we go. AlCl3. Very nice. All right, magnesium sulfide.
Ionic.
Ionic. Okay.
Mg2S. Wait, don't they cancel out on this?
Yes, they do. Magnesium has a +2 charge. Sulfur has a -2 charge. Equal and opposite
MgS.
reduces to MgS. Very nice. Okay, number 35.
Ionic.
Okay.
Li
LIS.
Li2S.
Do you guys agree? Li2S. Does sulfur have a -2 charge?
Yes.
Yes.
Yes. And then lithium has a +1 charge, right? So it does have to be Li2S. Okay. What about number 36?
Covalent.
Oh, covalent.
Covalent. Okay.
P2S.
P2. FL.
Yeah, FLC.
FO5.
So fluorine, I'm gonna tell you is just F, not FL. That I've actually found on a test where they actually wrote fluorine FL, which is kind of funny. But just heads up, it's just F, not FL. That's okay. All right, so P2, F5. Very nice. Okay, number 37.
Ionic.
Ionic.
You sure?
It's
Carbon.
covalent because of the prefix.
It's covalent because of the
Yeah.
prefix. And what about carbon? Is carbon a metal?
No.
No.
No, carbon is not a metal, meaning it must be non-metal. So then 37 is
Covalent.
covalent. Okay. Now what about the formula?
EF4.
You said C,
L.
F4. CF4.
you said CF4? Okay. So covalent. And then CF4. Okay. All right, number 38.
Ionic.
Ionic, okay.
S.
All right, so what's the formula look like?
Na, sodium.
No, they cancel out.
Na3P.
Na3P. Do you guys agree?
Yeah.
The sodium has a +1 charge, phosphorus has a -3 charge, so that 3 comes behind the sodium. Very good. All right, 39.
Wait. Ionic.
Ionic, okay.
E. Okay.
Okay. Okay.
Ki.
Ki. All right. So we've Ki because potassium has a +1 charge, iodine has a -1 charge. So you're left with Ki. All right. And finally, number 40.
Ionic.
Ionic, okay.
GAS.
I heard GAS. Do you guys agree?
Yeah.
Mm-hmm.
What is the charge of a gallium ion?
Negative? I mean positive?
Okay, gallium has positive what charge?
3.
Gallium Ga has a +3 charge. What does sulfur, what's sulfur's charge for sulfur ion?
-2.
-2. So do we need to keep GAS or do we need to change something?
Ga2.
Yeah.
Ga2S, and then
5.
you said 5? What's the charge of a gallium ion?
3.
So something that I think would help, because I mean, this is a lot of information and having to like process where it came from, what it means, all that, like going through all of that, like having to pull it from your periodic table, that's not easy. Like we're getting into real like serious stuff here. So what I think would definitely help you is to write it down. Definitely one, have a periodic table with the charges on the top. So group 1 through 3, you need to have the charges on the top and the number of valence electrons on top. Always, that will always help you. The second thing that'll help you, especially with naming, is to write it out. Like eventually you'll get to a point where you can do it in your head, but even then, like when you're playing with charges, like you'll always have access to scratch paper. Okay, so make sure you just like write it down. So like start by writing down the elements with the charges there, and then if you need to draw the arrows, draw them, and to make sure that you get the right answer each time. Okay? So I was gonna go over balancing chemical equations with you guys today. I feel like this was a lot. I personally think that I would rather give you guys extra time to practice this, to really make sure you get it down. And then next week, we can do chemical reactions, balancing chemical equations. And what I can do is I can make a video teaching it and I can go ahead, upload it so you guys can watch it. And then when we do Zoom, like I'll go through kind of like what we did today, like you guys are interactively solving it with me. And then I can give you practice problems. That would help pacing wise, because my goal right now is to make sure that you learn this, you have this down to a degree. So next year it'll just make your life so much easier. Are you guys like, do you agree? Is that okay?
Yeah.
Yes.
That's fine.
Okay. If you think that you're game for going ahead and like proceeding with balancing chemical equations, you can let me know. But honestly, I think if I post a video, let you guys watch it, try it for yourself, and at that point, if you know, like, hey, this is what's confusing me, I think it may be a little more helpful. But okay, so on the Canvas page, okay, on the Canvas page, let me see if I can pull it back up for you. Seriously. Mhm. Okay, so here down below, here's some of the resources that I posted for you guys. So where did the Zoom video go? I swear I had it up under here, didn't I? You guys
No,
been
you
able
say
to
you're gonna
access
put it on
the Zoom video from here? Like the last one?
No, you say you're gonna upload it on YouTube.
I had posted it right up under these.
Yeah, you can't see it. I know what you're talking about.
Because I swear I put it on here. Okay. That's why people
saw
are
it yesterday.
like, are
It's
we
on
supposed to do it? Say it again? Okay. Well, I'll try. I'll post it again. So I sat here and literally watched it upload. So this is weird. So I'll post it here and then I'll add it to YouTube as well, along with this one. But I just wanted to show you guys, and hopefully it'll open properly, what other things I added on here. And tell me if you can't see it, because like the screen sharing is being pretty specific right now. Okay, are you guys able to see this types of chemical compounds that popped up? No? Okay, well, let me try to share that. So it's still on the Canvas page then, or it was? Okay, so this is the second link that's up under there. So at first it just goes through Ionic Covalent. This is really good practice to just help with that instant recall. So like what Tyler's been doing this whole time is he's been trying to like memorize it, to like commit it to memory, which is great. And you guys will pretty much get there with majority of the elements, like just naturally it will happen. And this is a way to really help you to maybe go through this yourself without using the periodic table and see what you can recall. And if you're not sure about one, leave it blank and then go back and answer. And then as you start going down, you start seeing these parentheses. When you start seeing these, and even if it's not parentheses, when you start seeing more than 2 elements within the compound, you know you're getting into polyatomics, okay? And you will see that next year. This is a great way to get you prepared. No, you will not have to name the polyatomics. Not yet. Next year you will. But at least being exposed to it and being like, oh, okay, that's something I haven't really dealt with. But still, it still works the same way. First element, if it's a metal, ionic, if it's not a metal, covalent. And then here you have named the following ions. So basically this helps you with, just like identifying the elements based on the periodic table. But what it means by ions, so like, you know how when calcium's in a bond, it would just be like calcium, versus if oxygen's in a bond, it would be oxide. That's what it's talking about. So properly, there are a couple of polyatomics in here. If you look them up and name them, it will help you for next year. But for me, it's not like mandatory, but it's just the exposure. Okay, and then like writing the formulas here for the ions. So what this is talking about is just like if it was a phosphide ion, like it's just phosphorus, it's talking about just like P minus 3 or like P3 negative. So it's kind of setting you up for the swap and drop. And then as you go down, it's saying look up the formulas for these. So all of these are polyatomic. Like you can literally just type these into Google and then just write what they are. Once again, it's just exposure. Okay. So that's this file. That's what this is. It's just giving you as much exposure as possible and trying to like get you to immediately be able to identify some stuff.
Okay, so do we turn this into you as a grade or no?
So if you do this, this will definitely cover like a day's worth of assignments. There's a bunch of problems in here. So if you do this, just take a picture of it, like send it to me, and then like that'll be your assignment for the day. Because this is like new material and it's like quite a bit to have to work through. Okay? And thank you for asking that. And let's see, let me find, oh, okay. That just, okay. Let me find the other one so I can show you. All right, next one is the study guide. Study guide here. What? Okay, sorry. All right, here we go. So here's the study guide. Now this, you definitely should be able to answer, okay? So what I do suggest for those of you guys who are watching these lessons, who are watching the Zoom lessons, what will help you the most, okay, to prepare you for next year and what will help you equally with your grade is doing these assignments. So if like during this week, instead of doing the choice board, you do these assignments, they are so much more beneficial to you. So like maybe one day you do the study guide, maybe another day you do the other practice problems, and then at the end it'll be like a week's worth of material, and then, you know, it'll go in the grade book too. But this is so much more beneficial to you. Now the stuff on the choice board is great. It was meant to be simple, you know, quick, and kind of like touching on a little bit of everything. But if you have the advantage to like prepare yourself for ahead, please do so. But anyway, all the stuff on this guide is everything you were supposed to take away from this unit, like assuming it was taught, you know, at school or online. We still covered it all for this unit. So all of this was the bonding unit. You definitely need to know the difference between ionic, covalent, and then here you have the naming. Okay, but in here, notice you do have some transition metals. So this will definitely give you that extra practice. And when I check your work, I do check for accuracy. And some of you guys have got messages back for me like, you know, good job doing the work, but make sure you go over this. So if I do see something inaccurate like here, like maybe you got something mixed up, I will let you know. I'm not going to take points off for it, but I'm just going to tell you like, hey, make sure you correct this because you know how to do it right. Okay. So this is what I was going to give you while we were at school to make sure that you were able to cover all of this. Okay. And then, whoa. Oh yeah. Okay. And then finally, now this one, what I'm about to show you is quite a lot. Okay. And let me give you a heads up. I told you guys that I used to teach at Georgia State and at Perimeter College. This is what I gave my kids there. Okay, so this was actually kind of like copies of stuff from their workbooks. Some of the stuff you can do, some of the stuff is way above and beyond, but it was just all in one place, so I just kind of posted it together. So here, the types of chemical bonds. So basically just saying whether you see ionic bond, covalent bond, or both. So basically if you see like a polyatomic in there, you could put, you know, polyatomic, or you could just put both. This first page right here is something you can definitely do. Okay? You can definitely go through. If you do this page, that's what assignment. This next one, now, you can do this. We did go over the Lewis dot diagrams. We did, you know, go over like how to kind of draw them, and that's all these are. But basically what this is you draw like the Lewis dot structure for one element, then from the other element, and it literally physically shows you where the electron went to. Okay, this is something that helps visually. So like if you see the sodium, you see sodium has like has a +1 charge, we know that, but it has like one dot there for one electron, whereas chlorine's missing a dot. And then you can see that the electron from sodium is literally going to the chlorine. And then you have both of the ions hovering together. Sodium's, you know, happy that it was able to donate, but it's still just going to remain with positive charge. That's what this is showing. Okay, so this is something that we did not do in class, but if you feel comfortable doing it for practice, you can. If not, this is, like I said, this is kind of above. This right here, covalent bonding, definitely above. Okay, this is basically the same thing as the previous sheet, but it's showing how they're sharing, how they're coming together. If you feel comfortable with drawing this and you kind of like maybe watch videos, look up how to do this, great, not required. Okay, it just helps solidify your understanding. Okay, let's see. This is way above, this is way above. You guys will see some of this in chemistry next year, but most of this is actually AP Chem. Let's see.
Okay, how many pages is this one?
Say it again.
How many pages is this document right here?
Ooh, this is a lot, but there's no way you guys can do it all. Like, you guys just don't have the background knowledge to complete it. I just put it up as a resource so you can kind of see what's going to be coming.
Because I could probably do the first 5, but the rest of them you on your own.
Yeah, the rest of them, don't even worry about it. I didn't know how to break apart this document. I'm trying to see if there's anything down below you could do. Yeah, this is kind of above. Technically, you could still do these. Like, you could still look up the answers. Like, for these at the bottom that are kind of like short answer, you could definitely look it up, and it would very much so help prepare you. Honestly, this final document, all I would expect that you could do is the first page. That's it. If you do the second the 2 pages after that, the drawing, fine. Beyond that, do not even worry about it. But some of you guys already know that you want to go into a medical field or into a science field. If you already know you want to go into nursing, if you already know you want to go into engineering, if you already know you want to go into mathematics, if you already know you want to be a biology major or a chemistry major, or anything that requires the sciences, please look through this document. Even if it's not you working through it, because you don't have to work through it, look through the information that's here, because this entire document, all the levels, physical science, going through chemistry, going through AP chemistry. So this is chemistry 1 and chemistry 2 in college. Okay, so all the information is what you will learn through that time. And I know it's not easy. It's quite a bit of work, but the sooner you're exposed to some stuff, if you know you're going to that direction, it doesn't hurt. I mean, just kind of look at it, check it out. Okay, so that's pretty much all I had posted. I have no idea why the Zoom video didn't post. Let me post that too again. And I think I'll put it on YouTube to be safe, because that actually worked. So I'll put it both places. All right, so do you guys have any questions about maybe like the work, about what's gonna happen moving forward, anything like that?
Okay, so like this document that you have on your screen now, will you use this as a grade or extra credit? Like you
Kind
said,
of both, because I mean, at this point, all you guys are really doing is extra credit. Like, I've been replacing your grades first. So if you have missing work or zeros, those were the first to go. And then anything that was like a failing grade, that was the next to be filled in. And then it was like anything like below 80 and then below 90. So I'm kind of like working my way up. So really that's what's happening. I'm not putting in any new assignments because mathematically that doesn't help you at all. Like, everyone's grade would stay the same if I did that. So that's why instead I'm taking these points and I'm putting them into previous work.
okay. We don't have no tests or quizzes from you, do we?
No.
Okay, I don't see how other classes have tests and quizzes. Like, we not going to cheat on it.
Do other classes really have tests and quizzes?
Yes.
Yep.
I'm sorry, that sucks. I'm sorry. No, I'm not giving any tests and quizzes. You'll have plenty of tests and quizzes when you hit chemistry class next year, or environmental, if that's the route you guys have. But I just want to make sure you guys are learning. And I feel like if I throw tests and quizzes at you, you're more focused on your grade than actual learning. So no, I'm not doing that to you.
Okay.
Okay. Well, if you need anything, reach out to me. I'll have these things hopefully uploaded within the hour. And if you need clarification on what you can do to replace an assignment, I can go through it with you again. Just send me a remind message. Okay?
Okay.
Okay, guys. I'll see you later. Good luck with your other classes and stuff.
Phew.
All right, bye.
All right.
Bye.
Have a nice day.
You have a good day too.